This is an introduction to the AK2-55 system controller by Danfoss. The light at the top can be used for alarming, in which it will turn red, or green to indicate that there's no alarms. This function can be turned on or off. The display is a VGA display and requires no contrast adjustment. The keypad has several functions. Function keys F1 through F8 can be assigned in specific menus. F2 can be used in any screen to access the access code option. You'll be prompted for your authorization code and account code. The menu key will always take you back to the main menu. The edit key is typically used to make changes to fields. The direct connect adapter connects here. This allows communication between the 255 and your laptop or PC using the Danfoss AKS-65 software. Connect your direct connect cable here. UL regulations require that the door of the AK2-55 is a locked device that cannot be opened without a tool. To open the door, insert a slotted screwdriver, quarter, or other device to release the mechanism. Here's an overview of the inside of the Danfoss AK2-55. Here you'll find we have the baseboard and CPU board combination. The CPU is the smaller board and contains a sticker with the MAC address of the controller. This board is the inverter for the backlit display, and the display is found here. On this side we find the input board where inputs come into the unit. Also, communication connections are made. On this side we have the power supply. Let's take a look inside the details of the AK2-55 controller from Danfoss. First we'll look at the baseboard and CPU combination. Here you'll find the 3-volt lithium battery. Just above the battery is the battery jumper. The board is marked with 3 terminals, 1, 2, and 3. To retain the settings in the controller, the battery jumper must be across pins 1 and 2. Next we'll look at the rotary address switch, which is used to give the 255 its number. Addresses always start at 0 and can go as high as 9. Here we find the RS-485 function jumpers. These would get removed under normal situations unless you're using Modbus RS-485 I/O nodes. Here we'll find the USB connection, which can be used for loading software, saving programs, and downloading programs into the controller. The CPU reset switch for the 255 controller is found here. Pressing it once will reset the controller and restart all functions. The power supply board for the Danfoss AK2-55 is found here. Moving down through the controller, we see the incoming power, which can be any voltage from 100 to 240 volts AC. Next, we find 5 ports for I/O connections. These are echelon based. The connector for the RS-485 communication is found here. It is polarity sensitive. Note the terminals marked DY and DX. This connection is for the internal alarm relay. Here we find the modem connection and finally the Ethernet connection. Let's take a look at the AK2 modules used for I/O communication to the Danfoss 255. Here you see the 24 volt DC power supply. Next, the communication module. This module will start each group of boards. This module is usually known as the combo module. This one has 8 inputs and 8 outputs for relays. This board is used for inputs or dry contact digital inputs. Next, you'll see the Danfoss stepper board. This stepper module can drive 4 stepper valves. This is a pulse module used to read up to 8 pulse inputs, typically from kW meters. And lastly, this module reads 4 analog inputs or 4 digital inputs at the top and provides 4 analog outputs at the bottom. This 24 volt DC power supply can be powered with AC voltage from 100 to 240 volts. It provides 2 24 volt DC outputs. This green indicator light means we have power coming to the power supply and the output is not shorted. If the output would be shorted, this green light will go out until the short is removed. Moving on to the communication module, you'll see the pattern of lights here indicates good communication. Status 1 should blink, status 2 and 3 should be on steady, along with the power light. At the top, we have the 24 volt connection. This module can be powered with either 24 volts AC or DC. The other connector is for I/O communication back to the Danfoss 255. Note the location of the termination resistor, since this module is the end of the I/O loop. The cover of this module and other modules can be removed by squeezing the right and left side and pulling toward you. This reveals the fuse inside the COM module and gives us a better look at the address switches. The address switches are important for setting up I/O points. This module usually is known as the combo module. It contains 8 analog inputs or 8 dry contact digital inputs at the top and 8 relay connections at the bottom. This is what's considered a full-size module. There's 3 modules that are full-size. This combo module, another module which is relay only, and the stepper module. At the top you have 8 inputs that can be used for pressure transducers, temp sensors, 0 to 10 volt inputs, and dry contact digital inputs. There are 2 locations where plus 12 volts DC is provided to power sensors, along with a plus 5 volt location for sensor power. Some modules may be equipped with recessed override switches. To override a load, simply move the switch to the left or the right depending on whether the load should be turned on or off. When the load is turned on or off, indicator lights on this side will remind us that we are in override, and the green light will indicate whether the relay coil is energized or de-energized. Right now, our indicator lights tell us that relay number 4 is in override and the relay coil is energized. Relay number 5 is in override, but the relay coil is de-energized. To remove the cover to get to the fuse locations, first depower the communication module. Next, squeeze the right and left side plastic strips and pull toward you. Here we see the location of the 5 amp fuses. To return power to the board, replace the override switches and the cover and power up the communication module. Here you see the terminal strip for connecting the loads to the combo board. Each load gives you a common, normally open, and normally closed connection. Relays on the board are fused at 5 amps and 230 volt is the limit. Next, moving to the analog input board, you see a very similar arrangement for inputs. The COM light would turn red if there's a communication problem with the AK2-55. The bottom row also contains inputs, but in a reversed fashion. When in doubt, remove the cover, look at the legend on the bottom if there's a question about wire hookup. Here you see another type of module. This is a half-size module and is used to provide 4 analog or dry contact digital inputs at the top and 4 analog outputs at the bottom. The 255 will allow you to configure your analog outputs for either 0 to 5 volts, 0 to 10 volts, or 10 to 0 volts DC. Next you see the pulse module, used for reading pulses from kWh meters and other pulse output devices. We have 4 inputs at the top and 4 inputs at the bottom. And lastly, the stepper module. Power for the valves themselves are provided at the top. 24 volts DC or 12 volts AC will be wired here to power the valves. Indicator lights shown here will indicate if each valve is opening or closing. Connections to each valve are made here. Wire polarity is important. Consult the manufacturer's diagrams based on the valve you're using. Let's take a look at the communication module used to communicate to AK2 modules. At the top we have the power and communication connections. For TP78 communication, such as this, communication modules must be daisy chained. The resistor shown here was removed from the plug inside the AK255 and placed at the last module on the daisy chain. This module can have 9 modules plugged into it. Upon power up, it will recognize the modules installed. Address switches at the bottom set the address for the communication module. Upon power up, the communication module will recognize the position of each board. Board number 1 is shown here. Board number 2 is shown here. In this example, we have the address dials set to 0, 0, 1, which means with this being our first load, the relay assignment would be 1, -1, and 0.1. Next we'll cover replacing or adding an AK2 module. Note that on each AK2 module the part number can be found here, should it be needed. The first step is to depower the communications module. This is an important step, otherwise the module could be damaged. First, we'll remove any connectors with wires attached. To remove the module, first we must unlock the tab from the DIN rail. First starting at the top, then the bottom. You'll note that the red tab stays in place. This indicates that the module is unlocked from the DIN rail. Next, lift the module directly toward you. To reinsert a module, first line up the Z connector, then push the module into place. It's important that it's lined up with other modules on the group. To lock the module to the DIN rail, press the red tab at the bottom and the top. The last step is to reconnect any terminal strips and reapply power. This condition indicates a communication loss between the AK2 modules and the 255 controller. Note on the communication module, status 1 is on steady. This is not a normal condition, and the error light is lit. On extension modules, note the red blinking COM light. This indicates communication with the host controller, which is the 255, has been lost. To troubleshoot this condition, wiring and voltages must be checked. Here you see the normal status has been restored. On the communication module, status 1 is again blinking and the error light is now out. On extension modules, the red COM light should be out to indicate proper communication. Today we'll be looking at rack control, condenser control, and circuit control, along with other features of the Danfoss AK2-55 controller. Let's talk about authorization, account codes, passwords, and audit trails. In the 255 controller, you can enter an access code at any time by pressing the F2 button on your keypad. You'll see a screen pop up like this, asking for an authorization code and an account code. Let's log out and log back in so we can see how this works. Once again, you may press the F2 button and be prompted for a code. After each set of numbers, you must hit enter. You can verify that your code was accepted by pressing the F2 key once again. This will display your level of authorization. Another way to log in is by going to the authorization screen. This will allow entry of your authorization code and your account code. Remember to hit enter or OK after each entry of the code or account code. It's possible to log out in this screen, and it's also possible to view the audit trail. The audit trail can be viewed without an access code and displays the contents of changes made, when they were made, who made them, and whether they were made via network, modem, keypad, or a direct connection from a laptop. It's possible to get an overview of the refrigeration system by first selecting refrigeration, the rack, then rack overview. This screen shows us the status of compressors, condensers, and circuits, along with displaying the refrigerant, oil type if programmed, suction pressure, and discharge pressure. Here you see the status of each condenser fan, compressor, and evaporator. It's possible to get more details on any of these items by selecting it. To back up, escape will take you back to the overview. We can get more details by selecting an evaporator, paging down. Here you'll find defrost runtimes, refrigeration runtimes, cycles, last defrost cycles. Let's back up, take a look at the rack overview screen, and see the cycles and runtimes for condenser fan relay number 5. Here you see the list of evaporators and sensors, their current temperatures and targets. The address in the middle is the board point where the sensor is connected to the AK2-55 input board. If we want to find out what defrost times are programmed into the 255, we can check the Defrost Map. This will list all defrost based on a 24-hour schedule. Here you can see most glass door cases are using a staggered defrost time. Walk-in freezers are using multiple defrosts per day with staggered schedules to minimize overlap. Let's look at another feature of the AK2-55 called dynamic suction float. This option allows the rack to float the suction pressure up when specific cases have reached their target. It's called dynamic because it can switch between several cases. To see the settings, navigate to Configure Rack and Suction Info. The suction ID is listed at the top. Below that we'll find PSIG target of 14.3 pounds. This is the base target for this suction group. This group is allowed to float a maximum of 4 pounds. Let's take a look at how this would appear on the suction group status screen. Here you can see the new target for the rack is 16.5 psi based on a float of 2.2 pounds. Remember, 2.2 pounds was added to the base target of 14.3. Let's view the dynamic float from the evaporator. This screen tells us that it's currently floating based on glass door ice cream case 11. We can see that today it's floated by 2.2 pounds, and so far today it's been floating on this case 33% of the day. A listing of all cases that are included in dynamic suction float are listed here. As the case would reach its target, the rack would be allowed to float to a maximum of 4 pounds. As you can see, the float has adjusted slightly down to 1.9 pounds, giving the rack a new reference point. This rack's basic target is 16 pounds. We know that it's not floating currently because the float adjustment is set to 0. The reason for this is that the case temperatures that are floating the suction are higher than the target temperature. As we'll see in a moment, the case that's floating the rack is actually in defrost right now. Let's take a look at how this floating is set up. In the suction info screen, we can see that floating is turned on. This particular rack is floating based on a board point. The board point in this case is a calculation. This calculation looks at a target temperature of -10 degrees Fahrenheit, plus or minus 1 degree. As you can see, it's important to know that the rack cannot float more than 5 pounds. As we saw before, that means this rack cannot float above 21 pounds psi. We know that this board point is a calculation. Let's take a look at what's really going on in this calculation. Calculation number 1, as you can see, is used for floating. In this calculation, we're taking the average of 4 sensors. In this case, it happens to be ice cream glass doors. The average of these is 29 degrees because the case is in defrost currently. Next, let's take a look at services available through the rack service screen available to you, the user. Here you see the rack status screen. At the bottom of the screen, like many screens in the 255, you'll find several icons. Each icon will take you to another area where you can make changes, observe history, or just see board points. This icon is the service screen. Here you see options available to you. Options that you have such as overrides, which can be done with auto manual relays or auto manual inputs, or even sensor adjustments. Let's take a look at auto manual relays. If we need to override a compressor, in this case, it can be done through the auto manual operation. To do this, you would use your edit key to highlight the compressor you need to override. Let's say we want to override system 1A compressor in the on position. Select manual on, and the compressor will be overridden on. This override will stay in place until removed by the user. There are two ways to remove the override. It's possible to remove it by just hitting or selecting the reset button at the bottom, or we can simply go back to the point, switch back to auto, and the override is removed. It's also possible to override or offset sensors using the service screen. Let's go to the sensor adjustment menu. Here you see several options. The current reading is displayed, any offsets are displayed, and here we see more detailed information about the sensor itself, including resistance values and DC voltages seen by the input board. Let's take a look at options available to evaporator screens. It's possible to place a case in defrost or even suspend alarms along with offsetting sensors. Let's select a sensor. As you can see, once again, you have several options available at the bottom of your screen with icons. Let's go back to the service icon to see what's available. Here we can auto manual relays, auto manual digital inputs, offset and adjust sensors, put cases in manual defrost, view or change board points, or suspend alarms. Suspending alarms is done on a per sensor basis. For instance, if a case has 3 sensors and you override one sensor, only that sensor would be affected. The sensor offset screen is available much like the rack we looked at, to allow offsets to be placed for cases and to view input information. Let's say we needed to defrost a case using what's known as emergency defrost. Select manual defrost and you'll see your options for this case. The defrost operation can be changed from auto to manual on or manual off. The maximum time can be adjusted here if a defrost is needed that is longer than the normal defrost time. And here you can select whether or not you want to terminate based on time or other termination options normally afforded to the case. Next, let's look at the option of suspending alarm generation per sensor. In this case, if we switched the status from off to on, this case would be suspended for 60 minutes, allowing no alarms during that time. After 60 minutes, the normal alarm generation possibilities would exist. Next, let's look into the alarms. Setup of alarms, viewing active, acknowledged, and cleared alarms, and determining whether alarms were in fact sent to other parties so that a correct response can be made. Alarm setup is where most setups are made so that alarms are done correctly. Routing contains information about how the alarms are sent out from the controller and which alarms are sent from the controller. Starting at the top, you see an alarm relay is activated. These action numbers can be defined on any alarm. It's really a way to group alarms into 8 different groups, because some alarms may be routed in one way and other less important alarms may be routed a different way. Here you can see we've selected any alarm with action number 1 to go to alarm relay, here labeled as relay A. There's no delay before the alarm can activate the relay, and the relay will stay on until all alarms have cleared. We can find more information about this alarm relay by selecting this arrow to the left of relay A. Here we see a name was given to the alarm relay called Alarm 1. It's important to note that this alarm relay does not exist on this controller. At this site, Rack 1 is considered unit number 1, but the alarm relay is actually residing on controller 0. So this controller has been set to send its alarms to unit 0 alarm relay, defined as Alarm 1. If we page down, we can see more information about the setup of the alarms. Here we see that the front LED on the front of the 255 will turn red if any alarm exists, defined as any alarm action 1 through 8. The relay will not turn back to green until all alarms have cleared. Next, we can look at alarm setups going to modem numbers and networks. Here you see the first phone number is set to grab action number 1 alarms. After 1 minute, dial those out, not send out clear messages, and stop dialing out when the alarm is cleared. Let's check the setup for the phone number 1. Here you can see it's been programmed to dial out to Triangle Refrigeration using this phone number. The person on site or the installer has determined that to send the alarm out to this number, they first must dial 99, The schedule has been set to standard, meaning the alarm will dial out any time during the day and any day during the week. If the schedule is not set from standard and left in the not used position, no alarms will dial out. Let's page down to verify that the setup is correct. In this case, the 255 is programmed to know that the modem exists on unit 0, the Ethernet is connected to unit 0, and there is no alarm logger installed. From the main menu, we can find information about alarms that may have occurred in the past and alarms that may be in pending mode before you leave the store. Let's take a look at the alarms menu seen from the main menu. Here we have the option to view active alarms, acknowledged alarms, and cleared alarms. It's important to note that the alarm status is used by many mechanics and technicians to view the status of alarms that may be pending before they leave the site. A useful tool is using the alarm status screen to check for any alarms that may be counting down, indicating a problem that could exist. Here, each alarm configured in the controller will be displayed. If there are no pending actions, the state will read OK. You can page down to see all the alarms. This indicates that the box door for this evaporator is actually open and the alarm has tripped. This particular alarm is set to log only and will only be viewed in the active alarm screen. If you would find a state reading in a number of seconds and decrementing, that would indicate that the alarm is in alarm pending mode and may need to be checked before you would leave the site. Next, let's take a look at options available in the alarm menu. Active alarms would show alarms that are active currently and may have stayed there for an undetermined amount of time. Here you can see the box door open alarm we saw earlier. This will display the settings for the alarm, the reading for the alarm when it took place, and whether or not the alarm has been acknowledged. Here we have the option to view alarms that have been acknowledged but are still active. In this case, there are no acknowledged alarms. Cleared alarms will display any alarms in the log that have been an alarm but have subsequently cleared. Here you see several alarms for the freezer box. We have available 59 pages worth of cleared alarms. At the top we can see that there are a total of 234 entries in this log. It's possible to acknowledge all alarms, but a confirmation must be made to ensure that is correct. It's possible to page down through several pages worth of alarms to find any alarms you might be looking for. Here we see an alarm for system IC GD1-09. It alarmed on January 18th, 10:58 a.m. and at the time was reading 36.5 degrees Fahrenheit. The temperature currently in this case is negative 10.2 degrees Fahrenheit. It alarms anytime it's above 5 degrees for 90 minutes and is not in defrost. It's possible to get more details about this alarm by selecting it. This tells us some important information about this alarm. For instance, we know this alarm is set to dial out to triangle refrigeration, and it's important to note that it did so successfully on January 18th, 2012 at 10:59 a.m. Next, let's look at miscellaneous alarms. These may include individual points that don't fit the current conventions for alarms. To access miscellaneous alarms, you may view those through the alarm menu or through miscellaneous. Here you see the normal groupings for I/O points: relay outputs, sensor inputs, on-off inputs, variable outputs, and other controllers. Let's take a look at on-off inputs. Here you find an alarm configured for System 1 oil fail. To view the details of this alarm and how it was set up, select the name. Then you'll find the number of alarms set and the characteristics of the alarm. Let's take a look at history options when viewing circuits. History options will be similar for other screens in the 255. If we check this sensor, we see the normal status, but like many screens, we have other options available at the bottom of the menu. The camera icon will lead you to history. When entering the screen, typical default information will be populated. There are several options available and afforded to you at the bottom of the screen. For instance, we know that the listing of the data will be done at 1-minute rates. This rate can be changed to better match the setup of the individual point. For instance, note that at the top of the screen, these 3 points that are important to this evaporator are logged on 10-minute intervals. Because of that, if we view the graph at 1-minute rates, we're simply going to see duplicated information. Let's change this rate to 10 minutes to get better information and more information on the same screen. In this case, we're in text mode, so we simply see tabular data for the 3 points listed at the top of the screen. Other options are graphs, allowing you to scroll backwards a page at a time, and obviously we could scroll forward in time as well. This indicates a case defrost. If we want more resolution on the graph, we could change the maximum scaling seen on the left side. To return to text mode, simply select the text button. The Stat button will give you important statistical information on the 3 points listed. Each point listed at the top is given a data point number, here seen as DP1, 2, and 3. We can tell based on the screen that data point number 1 is the temperature for frozen food glass door 3-03. And it's important to note that in the last 24 hours through 4:30 a.m. today, the minimum temperature was -6.8, the max temp was 37.5, and the average temp in that time frame was -3.4 degrees Fahrenheit. The relays are listed here, including the refrigeration relay seen as DP2 and the defrost relay seen as DP3. This information tells us that the refrigeration relay was on completely in the last 24 hours except for the 30 minutes for defrost. There was one cycle indicating there is only one defrost programmed for this case, and you here will see on percentages for each relay. The Select button at the bottom will give you options for other I/O points that may be available. Other important points about history are seen here. Information about general history setups can be found from the main menu, then selecting History. Here we see that history is being collected. Other status you may see are not configured or suspended. History can only be restarted if found in suspended mode with a supervisor access code. It's possible to verify that points are being recorded in history by selecting Configure History. Then set up history data points. Here you can see a listing of all points. The sample rate in this case is set to 10 minutes for each point. If we page down through the relays, we'll be given a display of each point, and we can see if there are any points that are not being logged in history. A point not being logged in history would read off for the sample rate. For instance, This sensor for DualTemp2-01 is currently not being logged in history, so it would not be possible to view history for this case. Let's take an overview of the miscellaneous screen, which contains many useful functions. Calculations are used to make decisions or copy sensors. Conversion factors can be used to build sensor types not already included in the AK2-55. Alarms gives you a link to setting miscellaneous alarms. The user screen can be used to display a list of important inputs or outputs on one screen. The service menu allows you to offset miscellaneous sensors and override miscellaneous relay outputs or on-off inputs. The status for the miscellaneous menu can be viewed through any of these points. For instance, if we wanted to view the status of any relay outputs programmed through the miscellaneous menu, we would highlight this option. As you can see, no miscellaneous relay outputs are programmed. If we wanted to make changes in the miscellaneous menu, we would have to first select configuration. Calculations can be used to copy sensors. Calculations can be very simple or more complex depending on your needs. Here you see we have two calculations. Previously we looked at the floating calculation. This calculation finds the average of 4 board points. Units is used to define the output of the calculation. Because we want the average of 4 sensors, and we know that average will be in degrees Fahrenheit, the units is set to SI, meaning sensor input, degrees Fahrenheit. Style allows you to define what the calculation will be doing. An optional description can be programmed here. As you can see, 4 sensors are listed and the average is found. For the calculation to be effective, the result must be correct, and the current value will be reflected here. Let's take a look at another calculation. Here you see a calculation for global phase loss. This phase loss looks at 2 inputs. If either input switches to the on value, the phase loss will become true and be used in other parts of the 255 for important safety features. In this case, the calculation is programmed so that on-off input 1 or on-off input 2 becoming on will result in a current value switching to on. The true line is used to tell the calculation what to do if neither input is on. In this case, the calculation will be off. Another way of looking at the word true is to think of it as the word else, which is used in many PLC programming strategies. Conversion factors can be used to set sensor types not already available in the 255. In this case, you see a liquid level was utilized that did not already exist in the 255 controller. The installer knew that the minimum input for this liquid level transducer would be 0.5 volts DC and the maximum output would be 4.0 volts DC, corresponding with 0% or 100%. This liquid level name was defined and then selected out of the sensor type list in the rack. Let's say we wanted to create a calculation, in this case the simplest calculation, which would be a sensor clone. Because we're in the status screen, it's not possible to create a calculation here. So, returning to the miscellaneous menu, select Configuration. Next, Calculations. Now you see it's available to create a new calculation, which will be defined as calculation number 3. Let's say we wanted to create a clone, which is the easiest calculation based on the outdoor air temperature. We would simply need to scroll to the outdoor temp sensor based on a list of all sensor inputs. The calculation will go through a startup process, then display the results. To clean the calculation and delete other lines not needed, it's possible to select Delete for any lines left empty. At this point, it will go through a startup process again and give us the finished result. Because this calculation is not needed, and just for demonstration purposes, it can be deleted from this screen as well. Next, we'll talk about communications options. These include host communication, which is defined as communication between 255 controllers, I/O network communication, used to read inputs and control outputs, other nodes that are connected to the controller, rescanning, and I/O network overview. Let's start with communications. As we said, host network is a list of other controllers connected on the 255 network. These can be connected through a 2-wire RS-485 network or Ethernet. As you can see, there are a total of 3 units on this network, and all 3 are currently online. Unit 0, Unit 1, and Unit 2. Unit 0 is defined as the master controller. Next, the I/O network. List points is used to list points assigned. List nodes will list all the boards assigned and their status. Overview will give us more details about individual boards, including AK2 communication modules. And duplicates will list any duplicate nodes on the network. This is typically used during commissioning and installation. Rescan channels gives us the option to reestablish communication to existing boards or bring new boards online with the AK2-55. Let's take a look at list points. Here you see a list of all points in order by board point. We know they're in order by board point because the sort function is turned on. Currently we're looking at relay outputs, but we could switch to sensor inputs, on-off inputs, variable outputs, or other controllers, which could include rooftop controllers such as RTCs. List nodes will list the status of boards online on this 255. As you can see, all boards are currently online. Overview can be very useful if you are having trouble keeping boards online or troubleshooting. As you can see, there's a button on the right that allows you to get more details on AK2 communication modules shown here. Here we see 3 communication modules. Those IDs are 1, 2, and 3. The screen shows communication module number 1 has 4 boards, number 2 has 6 boards, and number 3 has 1 board. The OK status means that communication is active and no boards are lost. we can go one level deeper on any of these communication modules by selecting the address and pressing enter. Here you see important information about each board, including the type of board, whether it's configured in the 255, whether the 255 can see that it's installed, and any problems on the board. The supply voltage refers to the voltage used to power the COM module, and can vary from the actual voltage. This column shows us that the regulated 12-volt supply is a good voltage level. In similar fashion, the 5-volt supply is listed here. This temperature is a temperature recorded from the board itself, based on a small thermocouple incorporated into the board. It will commonly run slightly higher than ambient temperatures. All indications are that communication module number 2 is working correctly. If we back up to the I/O network status screen, we have the option to rescan channels. This would be done to bring boards online initially, or to re-establish communications with boards that may have gone offline. For most sites, the only selection that needs to be made on this screen at the top will be Channel Lawn Works. This is based on the type of I/O boards that are installed. If we wanted to rescan the network, we would select the Rescan Network option at the bottom and press 1 or 2. If we chose 1, the top of the screen would give us status feedback on the operation. A typical rescan will be completed in less than 1 minute, and you'll be giving a summary at the end of the rescan. Several general items are available in the Store Info screen, such as store name, the clock for this unit, operating hours, which are store hours, any holiday schedules, daylight savings dates, which can be changed, but should be left at factory defaults, any leak detector setups, notes about contact info, manager's override, which typically will override lighting loads, and options to change units for measure, languages, and other preferences.